area is constructed using soldier piling method. H-beams will be used as the major material of soldier piles. Before driving the piles, position alignment and orientation of the piles must be established. Piles will then be driven by vibrator hammer unit into the marked position. Piles shall be driven in the straight vertical position, otherwise driving will be difficult. All piles will be inspected for excessive camber or sweep. After completing the soldier piles, excavation of the first layer will be carried out. And then a temporary deck and the first whaler strut will be installed. Excavation for the second and third layer of base will be continued. The bottom layer will be completed by blending stone and lean concrete. The process of base slab concrete can be started. The station is constructed using a top-down method. In order to retain the soil and water pressure while commencing a deep underground excavation for main station boxes, diaphragm walls will be constructed. The trench is excavated using a mechanical and hydraulic clamshell, and then a reinforcement bar cage can be lowered down into the excavated area. The next step is pouring the concrete, which is carried out by Tremie method. This cycle is repeated for all 4 sides of the station. The diaphragm walls will function as temporary retaining walls during construction and also as a permanent retaining walls for the station structures. Before starting the excavation process, king post must be installed as a temporary support for the roof and floor slabs. The first excavation will be conducted and followed by the casting of roof slabs. With openings at the round of king post, the second excavation can be conducted. After installing the concourse slab, a concourse column will be casted, and then the third excavation can be conducted. Before casting the base slab, blinding stone and lean concrete will be installed. The final process is backfilling the roof slab by soil and compacting it by grader and vibro roller. EPB shield machine is not designed as a whole complete component. Shield machine assembly is located at the launching shaft beneath Pemuda Statue Senayan. This machine is formed by some parts which have special function for the tunneling work. When the TBM is completely assembled, it will be positioned facing the tunnel eye seal. The TBM will then be slowly proceeding forward. The tunnel eye will be broken by TBM roller cutter. TBM will then break out launching shaft and entering into the ground. Cutter head is the main component for excavating the soil. This project requires circular spoke-type cutter head structure and flat front shape. To simplify the excavation process, a chemical injection will be required to produce a soil excavation result that is suitable for discharge by the screw conveyor. The chemical will be injected both at the face of the cutting wheel and within the cutting chamber. This chemical will be mixed with excavation material by rotation of the cutting wheel and the mixing arms. After the cutter head rotates to excavate the soil disposal, it will be transported to a screw conveyor. The screw conveyor is used to deposit excavated material from the cutter head chamber onto the hose along the backup car. Soil disposal as a result of excavation will be transported from screw conveyor to hose system. The screw conveyor has one gate for muck disposal passed into the 14-inch hose. This hose will be ended at backup car number 1. Soil disposal from backup car area will be delivered by muck car to the cut and cover area. The full muck car will be hauled back to the opening by locomotive, hoisted to the surface and emptied into the muck pit. Another locomotive will go back to the TBM carrying the concrete segments and 3 empty muck cars. After the excavation cycle is complete, the shield jacks are left locked onto the previously built tunnel rings to keep the TBM tight into the tunnel face, and only enough shield jacks will be removed to allow the placement of one tunnel segment at a time. The segment erector can pick up the first segment from erector pickup area. and place it in the correct position in the invert of the tail skin. Each segment is 1.5 meter wide with 25 centimeters thickness. The segment hoist is then operated to place the remaining segments into the erector pickup area. The ring build is completed by inserting the key segment and tightening all the segment bolts. After the 6 segments have been installed properly, the shield jacks will then push forward and the excavation will continue. The tunnel is finished by installing a concrete invert, which is a permanent structure for the bed track of the MRTJ railway. When the machine have reached a designated distance, the machine will be arrived at stations. The final of arrival is at Setiabudi stations. And then the machine can be dismantled. One by one, the machine parts will be hoisted up to the surface. After completing the station and tunnel structure, the next step is to install all the mechanical and electrical components, including architectural works. All stations' entrance and exit will be located at the pedestrian area for easy access for the MRT Jakarta passenger. MRT Jakarta Phase 1 is expected to carry 412,700 passengers each day. Travel time between Lebak Bulus Station to Bundaran HI Station is only 30 minutes with 5 minutes headway. This indicates that the target of this operation is so that MRT Jakarta will be the primary alternative of public transportation. The final impact of MRT Jakarta will reduce the level of traffic jam and pollution in Jakarta. The realization of traveling with comfort and safe will be experienced by Jakarta citizens with this MRT Jakarta operation.